Hi everybody and welcome. Today we're going to be taking our knowledge of slope and applying it to actually solving for equations in slope-intercept form or in y equals mx plus b form. So again, we're going to be doing some calculations today, going through some processes of, algebraic solving, but again, leading it back into that idea of slope-intercept form. So first things first, a reminder of slope. And, we've done a lot of money examples and things like that, but we can also think about slope in the real world and in real life. So this is a ski slope. And quite literally, the slope is taking a look at, how steep is this line? Is that rise over the run? And honestly, this is pretty steep. If you don't turn and you go straight down, you'd be going very fast, very quickly. I remember when I was growing up, I lived in Massachusetts, so we'd be, go skiing up north, and there were some good mountains there, a lot more mountainous and hilly than Ohio for sure. And there was this one slope, and the first time my family went to it, it was like, and I'll draw it in the trees here, hopefully you can see this. It was like, gradually going down, and there was like this point, and then it just like all of a sudden like dropped off. And when it got to that point, obviously we're going from more of a flat slope to a very steep slope. So at this point, my sisters decided that they didn't want to do it, so they took their skis off and they walked themselves back up to the chairlift and took a ride back down. And then I decided that I was too lazy to do that and just went flying down. Didn't make it to the bottom, was definitely very scary, survived though. But again, seeing some examples of where that happens in real life and an application of, you can see slope change. If you look at grades on hills, things like that. If you see something like the 15% grade that they have, like the tractor trailer truck warnings for, again, that's 15% grade. That's an example of slope. So some things to think about here, but at the end of the day, it's all a big application of, things we can see in the real world. We just have to find it sometimes. So here's one example. All right, so reminding us and bringing us back here, slope. And this is just the measure of the rise over the run of an equation. And for this, we can see positive slope. It goes up. Negative slope from left to right goes down. Zero slope is like Ohio. It's just flat. And then the last one is our rocket ship, going straight up and straight down. We call this infinite or undefined slope, DNE, because it's infinite rise, zero run. Here, for our zero slope, there's no rise. It's all just left to right run. So a couple different applications here. You'll see this come up in a few different ways. If you ever see an equation like zero slope, it's going to be y equals something. If you see undefined slope, it's just x equals something. The other ones, though, you're going to have it in that y equals mx plus b form for both positive and negative slope. So a couple different formats that we're going to see here. But again, all things we've seen before, just a quick refresh and a quick review. So first one here, we need to find a line between those 2 points. So again, our line, we need y equals mx plus b. Well, we don't know what our slope is, so let's do what we were doing the other week, y2, y1, x2, x1, and we'll subtract them. So 5 minus 1 over 0 minus 3, and we'll get 4 over negative 3. Again, that is our m value, or our slope. And our b value, that's our y-intercept. Well, this happens when x equals 0. So x equals 0, y equals 5. That's our starting point. So our full equation here, we have 4 over negative 3, or negative 4/3 x, plus positive 5. Second, undefined slope. That means straight up and straight down. If we look at this on a graph, we're going to go over 7 and up 8. Well, it's just going to go straight up and straight down from x equals 7. So no matter what the y value is, x equals 7. And actually, that's our full final answer there. That's all we have to do for our second one. And for our last one, a different type of example again, y equals mx plus b. They're giving us the m value. They're actually giving us an x and a y as well, but they're not telling us what b is. So it's our job to take everything that we have and plug it in. So we have y equals 12. I should erase that, make that a little bit more neat here. So y equals 12. We know m is negative 2 over 3. We know x is 9, but we don't know b. So let's solve for it. So 2/3 times 9. You can either punch that into the calculator, or you can see that it's going to equal negative 6. Add 6 to both sides, and we'll get 18 equals b. So final answer for this one, we have y equals negative 2 over 3x plus 18. So the purpose of these three questions is to show you that using y equals mx plus b as your framework for each of these, we're basically just getting different quantities that we're plugging in and basically solving for m and for b each time. So as long as you do that, you'll be in good shape. If you have any of the quantities here, plug them on in, solve for the missing stuff, and you'll be able to write your full equation of your line. And that's our goal for today. So as always, any questions, please let me know. I'll see you in Teams very soon. And